Hello everyone. In this session we will continue to build the geometry of our bridge, and this session we will define the substructure of bridge, which will include the foundations, columns, and the abutment. This bridge will have an integral abutment, so we will define integral action in our supports. So to continue building our substructure, firstly we need to add two extra stages, and you will see that we are going to use those two extra stages to define our integral action in our supports. So we can go to File, Project Configuration, and here in Composite Beam tab, just add stage 3 and stage 4 to our model, and later on I will explain why we are activating these extra stages in this model. Click OK. Now we define our foundations, and before defining the foundation we need to define our soil properties or soil strata. So in ADA, to define soil strata, you can go to Structure and here Stratigraphic Profiles. So click this one. I will define two different soil stratas, one for our abutment foundation and the other one will be for our pier foundation. So to define the stratas, as you remember, we click the plus sign here to add a row, and I'm starting to name my abutment soil strata, so I name it as abutment dash soil. In this project we have just one ground elevation, so just define those as 0, and these 0 numbers are referring to our global Z direction. So the start of our soil strata will be starting from our 0 y or 0 y global coordinates. And for water elevation, let's put it at for example -10 meters. Also I add another one for our pier, so I name it as pier soil. I will define them as 0, 0 again. And here also let's assume that it will be -10. In the next tab here, you can define the soil properties or types of soil and their thickness here. So for the first soil strata, which is abutment soil, I will insert this property. So abutment soil, start by clicking here plus, the rank is starting from number 1, and for example let's say the thickness of first layer is 2.7 meters, and if you see here and check here, you will see that we have different kinds of soils here in the library of ADA. So for example, for first layer I'm going to use silty sand from ADS library. But remember, if you have your own soil properties, or if you want to define a customized soil, you can click this 3 dots button here And as you see, the soil spreadsheet of ADA will be opened here, and you can always start to add your custom soil here by clicking this plus sign. You can name it, and afterwards you can assign the soil characteristics, values, or parameters to your own soil. Here in this structure, in this model, we just use the already defined soils from ADA's library. So let's define another layer for this strata. So second layer, and I define it as 3 meters. And for this, let's assume it's clay 4. Number 3. Five meters. Clay 5. We can also define a number 4 as 4 meters. So as you see, this is an example that just here I'm showing you how to define your soil strata. So it depends on your example or on your soil properties. You can insert as much as layers or properties that you need here. So let's say this is our abutment soil strata, and by clicking here I'm going to define another strata for my soil under piers. So again, we start with clicking the plus sign. Number 1, 3 meters, clay 4, number 2, 5 meters, clay 5, number 3, again 4 meters, let's say, same thing, and number 4, let's say it's the final layer of dense gravel. So after defining your soil strata for abutment as soil, click OK. So right now that we have this soil strata, we will use this in definition of our deep foundations. So the next step is to define the properties of our deep foundations. So to define foundations in ADA, you can go to Structure menu and Foundation Models. As you see here, we have shallow and deep foundations. So in this example, I'm going to show you the deep one, but shallow foundation is as well as almost same as deep. So you can check it out later, shallow. Here I'm going to show you how to define the deep foundation. So as you see here, it's again is an spreadsheet format. So we start by adding our deep foundation properties here in this spreadsheet. So I click plus here and name our foundation. For example, the first one will be abutment. And here in this part, you define your soil profile or soil strata that we already defined. So it was abutment soil. Here you define the concrete material for foundation. Let's use concrete 030. And here, because we don't have any slabs in our foundations, I will just leave them as 0. Also, if you want to define the foundation properties, visually to see what numbers you are defining, you can always click on one of these cells and right click, and here as you see we have a detail option here. If you click detail, you will be able to assign all of the parameters and dimensions throughout this dialog box, and it's much more easier, and it will help you to see the dimensions and properties when you are entering those. So as you see here, the name is abutment, material is concrete 030, and the soil strata is abutment soil. No slabs here in these foundations, so we will leave these as 0. Second tab here, we don't have any columns in our structure, so we leave all of these also 0. Here in footing tab, we will assign the dimensions of our abutment foundation, so it will be 1195 meters by 1.2, and we will assign a thickness of 0.10, and we will add our abutment walls over this thickness, so it's this thickness is kind of fictitious. And the next step is define the piles. So here we insert the properties of piles. Let's say the installation is the driven piles. The work will be point and friction. Let's define all of these pile head and pile end as fixed. Pile length, for example, 12 meters. No buckling lengths in this example. Here you can select the shape of pile. So if you click on this icon here, you can go to steel, and let's say we select an HP section here, HP 310 by 110. Let's pick this section here. And if you remember, you can always check for section properties by clicking to this icon here. So select this section here, click OK. This will be our shape of our piles. The material, let's use our 350 AT. Here we leave all of these as default, and in this part, as you see, if you want to perform pile design, ADA is able to do that. So here you just need to assign design specifications for pile. Right now I don't have anything, so we are going to define a specification for pile design. Just click these 3 dots here, and let's add a new specification. So I name it as pile design. It will be a verification, and let's pick up a 606 verification. So click OK, and right now if you click this drop down, you will see pile design specification here. The other values we keep here as they are, and final here final tab is the layout of our piles. So here we will define the layout of piles under our abutment foundation. So we start here with clicking this plus sign, and we will insert the X and Z coordinates of the pile heads, and Z and X coordinates as you see here, it's shown here. So let's start from the first pile. It will be located at the middle of a foundation. So as you remember, the width of foundation was 1.2, so here I insert 1.6, 0.6 meters, and the other numbers will be as you see here. So as I inserting these coordinates here, ADAs start to show you the location of piles. So the second pile will be again 0.6 Z and 2.97. So the distance between the piles is 2 meters. Same 0.6, 4.97. Again, 2 meters more. 8.97, and finally the sixth pile will be 10.97. So as you see here, I have defined my piles under abutments in one row. So I click OK, and you will see that the spreadsheet has been filled for my abutment foundation or deep foundation. And if you remember, we need to define another foundation for our pier, so I add another row here. And we can name it as pier. Soil strata will be pier soil, same material. And right click, detail, and here we start to assign our properties for our pier foundation. So the name is fine. Column, we don't have column yet, 0. Footing, here we will insert the dimension of our foundation, which is 3.5 meters by 3.5, and the thickness of 1.25 meters. And here, as you remember, as before, we define our piles. So it will be a driven pointed friction. Let's put it as fixed, and in this case I'm going to define the lengths of piles as 8 meters. So the shape will be same, still HB. .360 by 132, or you can use the section that we have already used for our abutments. It was 310 by 110. So let's go with the same one, 310 by 110. Click OK. So material will be G40 21 350. And here again we are going to assign our pile design specification to this pile or foundation. And finally, next stage will be defining the layout of our pier foundation. So here we start by inserting the coordinates of piles and foundation. So the first one is 0.5 by 0.5. Beta angle is to rotate the pile shape or section around this axial local coordinates. For now we keep it as 0, and here you can define your piles with some angle or slope. That here I'm going to use this option in ADA. So let's put a lateral angle of 45 degrees for this pile and vertical angle of -18. And all of these numbers are according to your global coordinates on the foundation. The second pile, I'm going to put it as Z3 x 0.5 -45 and 18. Third pile 1.75, 1.13, all 0, so this one will be straight. Fourth one 1.13, $1.75 and 0. Fifth pile is 2.38, 1.75 and 0 angles. The sixth pile is 1.75, 2.38 zeros. Seventh 0.5, 3 meters, -45 degrees and -18. And finally our eighth pile will be 3 meters for Z and 3 for X, 45 degrees and 18 degrees. So here we have defined our pile coordinates and arrangement. So we will click OK, and as you see, our pile foundation, our pile deep foundation is also generated here. So click OK. Don't forget to save your model. In this stage, we start to build the abutment walls by using finite element plates of ADA. So in this example, I'm going to show you how to define your finite element plates manually, and we will build the abutment wall as a single wall. But as you will see in the next sessions, we also have a generator to generate abutment walls and wing walls. So I will talk about that one in our next sessions. But here, in order to show you if you want to do it manually, or in any case, if you want to modify the generated abutment, you will be able to do that using the technique that I'm going to show you right now in this tutorial. So we are going to start by building our first finite element plate to model the abutment. let's start the defining of our finite element plate by adding 4 nodes at the bottom of our abutment here. So if you remember to add nodes with using spreadsheets, just go to the activate node icon, activate it, and press Ctrl H. And down here you can add new nodes. So let's name them as 1001. So it will be normal node, and the coordinates you can add it here. The x will be 0. The y is minus 4.52 meters. Z will be 0. Another node, normal node. Zero and minus 4.02. So as you see here, I'm building a finite element model or a finite element plate that has a half a meter's dimension, and it's a square. The next one, 1003. We have x as 0 minus 0.6. And same number here as y. And finally the fourth corner will be 1004 minus 0.6 and minus 4.52. So I just copy and paste this here and click OK. So as you see here, I have generated 4 nodes. To start building my abutment. So to add our finite element plate, you just need to go to activate plates and click this plus sign here and start to add your properties. So as you see, the dialog box to assign properties of your finite element plate will pop up here. So I'm going to add properties here. So the thickness will be 1200 millimeters, the thickness of abutment wall. Material, let's use concrete 030, and let's assign it to our dead load here. And here to have the design of reinforcement for our abutment wall, we can assign here orientation system to our plate. So when we are checking for results and after the analysis, ADA will be able to design our reinforcement of our abutment wall. So to define the orientation system, just click this 3 dots icon here and start to add a new row. And let's name it as wall 1. The X and Y and the directions that you see here, they're mentioning you the local and global axes. So the small case X and Y's that you see here above, they are the local coordinates of your finite element plate, and the capital letters here, they are the global directions. So in this case, I want my local X to be exactly the same as my global X. So here I define this as 1, and also my local Y in my finite element plane, I want it to follow my global Y. So here I put 1 and change this to 0. So my local X will follow my global X, and my local Y will follow the global Y. And here in specification, you can assign a design, a specification, and ADA will design your abutment wall as well. So here I define a 6 design. And for covers, let's change the covers to 70 millimeters, for example. So this one was wall 1, and you will see that we will define another orientation for the other abutment wall and the other end of bridge. So click OK, and here in drop down we assign this wall 1 to our finite element plate here. So the other values here are fine, we don't modify or change them. Click OK. So as you see here, I have generated the finite element plate. It's the first finite element plate for the abutment. And if you want to check for the orientation, you can always go to View Options, O, and in the Attributes, Plates, you can check out here for local axis system. So as you see here, my local X is exactly in the direction of my global X, and local Y is in the direction of global Y. So the next stage is to just generate or copy paste this wall or this finite element laterally and vertically to have the full wall under my bridge. So select the finite element plate, and if you remember, the dimensions was 0.5 and 0.6. So here I'm going to copy it on X direction from each 0.6 meters. Okay, and hit Ctrl V. Okay, it will be 17. To have my abutment wall. Of course, this is an example, so it's up to you to copy paste or modify it according to your dimension of the bridge. And let's copy them again for to define them in vertical direction. In a vertical direction, I will copy and paste them for 4 times to have a 2 meters wall. So select all of those, Ctrl C. In Y direction from each 0.5 meters. Okay, and Control V. So as you see here, I have my abutment wall for it was 2 meters height, and you need to make sure that your nodes from finite element plates, they are aligned with your supports or with the girders. So you can, afterwards you will see that we are going to connect our girders to our finite element plates, and you need to have a node in both of the entities, both in the finite element plate and the end of the beam, to connect them together. So just be sure that you have same node aligned with the girder under of each of your beams or girders. So the next step is to generate the same wall in the second end or other end of our bridge. So again, I copy all of the members or all of the finite element plates, and I will paste them in the end of bridge. So Control C, it will be Z direction and 96 meters. Okay, Control V. So as you see here, it's already copied here, and right now I have the abutment walls. For the second wall here, as you see, I've used if you double click the plate, you will see I've used or it's automatically copied as wall 1, but we don't want this. We need to define a new one as wall 2. So here I'm going to double click this and click these 3 dots, add a new orientation as wall 2, and here we want our X to be exactly opposite of our global X. So our Z will be in the opposite direction. Assign wall 2. Okay. So if I select all of these plates, Control H, orientation system, right click, replace with wall 2, and click OK. Wall 2 will be assigned, and if you want to view those, just go to the graph attributes, apply, and activate it again. So if I check my wall 2, you need to define modify this one as well. So this one will be 1 and this one will be 0, and also assign your design here and the covers same as abutment 1, and click OK. So right now I'm going to try to reassign again wall 2. Okay, so right now if you check, you will see that my local Z is in this direction, and it's more convenient that define your local coordinates like this, because afterwards if you want to add some soil pressure here, it will be very easier for you to just assign soil pressure according to your local coordinates and with a positive value. So it's always better and easier to orient your finite element plates in this way. So as you see here, we have built manually our abutment walls. So don't forget to save your model. Now we are going to connect our girders to the wall using ADA's rigid links or rigid elements. So go to the member mode and click add sign here and start to clicking the node from the wall to the node that it is under the girder, like this, and define the behavior as rigid. So click OK. And also don't forget to activate these rigid links from stage 3. So after stage 2 we will have the integral action in our support. So because of that we will activate these rigid links starting from stage 3. So here, as you see in this window, we have effective at stage, and here I'm going to make them effective from starting from stage 3 and click OK. And also, if you remember these supports that we have here, we need to remove these supports to allow the force transfer from the girders to the wall. If you don't remove these, all of the force coming from bridge or girders, they will transfer through these supports to the ground. So we want the forces coming from beams to be transferred to the wall. So these supports here, they should be deactivated from stage 4. And that's the reason why, if you remember, in the starting of the model, we added 2 stages to our project. So first of all, let's select these supports. 4, and also the ones in the other side. Just hold Control. So you have 8 supports selected. Control H. And here you can define that remove the supports in stage 4. So replace stage 4. Click OK. So these supports, they will be active starting from stage 1 to 4. But after stage 4, they will be removed. And all of the force will go through our rigid links here. It will go through our rigid links to the wall. So if you double click this member again, the rigid link, you will see that in Advanced tab, it will be active from stage 3. So before stage 3, they are not there, and we don't have integral action. This is how we activate and deactivate a member or support in ADA. Click OK. Let's add the other rigid links also. So member mode, add, just click these 2 nodes here, same rigid, and active or effective from stage 3. Click OK. Same here. And the final girder. Also, we are going to define same rigid links in the opposite abutment or the other abutment. So click the nodes from wall to the girder, stage 3, rigid OK. Okay, and finally this one. Okay, so as you see here, I have connected my girders to the abutment wall. And don't forget to save your model. Next stage is to assign our abutment foundations to the nodes of finite element plates. So our finite element plates will transfer the force to the foundation. So let's add a support node here. So if you go to node mode and click Ctrl H, yeah, here. Okay. Okay, you have all of nodes here. Go to the final one here. Add a new node. Let's name it as 2000. It will be a support, and the coordinates will be x 4.5 and y -5. Also other one for the opposite abutment. So 2001 support, same coordinates for x and y, but for z will be 96 meters. Click OK. So as you see, this is the support node here, and you have it for the other abutment as well. To connect this node to our plates, we will use a master-slave relation of ADA. So we will select these nodes here, the bottom nodes of our abutment wall, and we will make this node master to those. So to select those nodes, first check for the number of this node. So its ID is 769. Just Ctrl C, copy it, hit cancel. After that, select these nodes, go to the node mode, window, Ctrl H, and here, as you see, you can assign that node as the master node of these nodes. So here I right click, replace, and the value is Ctrl V, or 769, the ID of the master node. So click OK and OK, and you will see here ADA has connected all of the nodes automatically to my master node here. And we can do the same action here. So just double click this support, it's 770, Ctrl C, just copy it, cancel, select the nodes here at the bottom of abutment with a window, node mode, Ctrl H, and here click this cell, right click, replace, and Ctrl V, or node number here, click OK and OK, and as you will see here, all of the nodes have been connected to my master node here. So right now that I have my master node here, I can assign my foundation to this node. So all of the force coming from the girders through the wall, they will be transferred to my deep foundation. So to assign a foundation to a support node, go to the support mode here, double click the node. In the support tab, here you have foundation model, and if you drop down this option here. You have abutment or pier foundation, deep foundation. That in this case it's our abutment, so I select this and click OK. So right now my foundation is assigned to this force, and if you want to see it, you need to just go to View Options dialog box or click hit O, and here in Elements activate the foundation view, click OK. So here, as you see, ADA will show you the foundation of abutment and the piles as you have defined in the dialog box. And as you see here, ADA automatically meshed the piles and assigned the springs or support springs, and the stiffness of these springs are according to our soil strata automatically. So as you see, it's very easy to define foundation and piles in ADA, and software automatically assigns all of the characteristics properties for the deep foundations. So we will use same technique for the other abutment. Just double click the support, go to this support tab here, drop down and assign abutment, and click OK to have your foundation assigned to your support node. So click OK and save your model. So up to now we have defined our foundation and abutment wall. The next stage will be defining our piers, columns, cap beams, and also the foundation for piers. So I'm going to finish this session right now, and in the next session we will continue exactly same this model to build our bent and piers here, and continue to build the full model of our bridge. Thank you very much for your time, and don't forget to save your model, because in the next section we will start exactly from this model. Thank you very much, and goodbye.